Here we have a portable energy storage, as it's mentioned here. This one is spinning on a plastic thing. Energy storage, so it has batteries inside. It's a box which looks like this. And the box itself can be charged, the batteries, from solar panels. It has an input somewhere, that one. We have a lot of details. So it's a portable energy storage. It has batteries inside. Sine wave, nice round sine wave. That is the inverter which outputs an alternating current. So it's just like a household connector. It's this one. I think it has just one, not two. We will see what's inside. So it's a good alternating current output. It has a cigar lighter that is outputting 12 volts at 120 watts. There's another direct current output which is identical to that one, but a different connector. So the large one is the cigar output and the smaller ones are the DC. Also 12 volts and 120 watts, 120 watts. Okay, it has USB outputs, 3 of them USB, and one of those it's quick charge free rated, so 5 volts are coming out from there, except the last one which can give 9 and I think even 12 volts, and that's the quick charge free. That's good for charging phones faster. It has a LED lamp that's not on this side but on that side. 500 lumens, high brightness display screen, output power, input power, electric quantity. So there is battery inside. That battery can be charged by solar panel, can be charged by alternating current also. So you can charge it from 2 sources. Okay, and it outputs 12 volts, 5 volts and 220 volts. The solar panel is of a better type. It's MPPT, it's not pulse width modulation, which is PWM. Maximum power tracking, bidirectional charging, car jump starter or charging by car. So it can give power to a car's engine and theoretically you can start a car, but I think that car has to have a small engine. I don't think a 2-liter, 3-liter engine can be started from this one because it says 120 watts. You can also charge the battery itself from the car, from the car's 12 volt plug. Batteries inside can be charged, so that's the input, from a wider voltage. Okay, you can charge your phone, your computer, your laptop, you can jumpstart your car, you can charge drones, you can power tools, a mini fridge, projector, printer, TV, fan, and so on. The same thing here, but in Chinese, I guess. Product features. And it has a lot of protection systems: intelligent monitoring, short circuit protection, overcharge protection. If you power the battery for too long, then it will cut off the power. Overpower protection, so you won't draw too much power from it. Overvoltage protection from the solar panels, I'm not sure. Overcurrent protection, temperature protection. Probably if the batteries are overheating, it will shut off the power. Battery balance system, so it's balancing, it's charging all the cells inside because there are multiple 18650 or maybe larger battery cells inside, so each of those have to receive its correct voltage. Okay, enough talking, let's open this box. That's the spinner. So we have one box, manual. Yes, that's the charger for the wall socket. Yes, I got the 220 volts plug, that's fine. That will go here, like so. And that's the output. It's like a laptop's plug. So it outputs 20 volts at 5 amps. And input can be 100 to 240. Okay, and you can power the battery itself. So that's the input of the battery. I think it's that one maybe. This goes there. You can charge it from the car also. That's the 12 volt plug. Now here's the battery. And that's it. The box is empty. Just foams. And it looks like this. It's not heavy. I mean, the car battery is much heavier. I think it's twice the weight of this one. It looks like this. More technical details here. Portable energy storage, LK-PS10 lithium-ion battery, 568 watt-hour, rubber feet, soft rubber, null and line. By the way, this was also in the box. It came in a larger box, so that should go in there, like so. Can move to the left or to the right. That's the DC, 12 volts at 10 amps. Short press, no. We have some fans inside, 24%. Let's see. Long press to turn off, long press to turn on. AC, 50 Hertz. AC is off, AC is on. Output 0.03011 watts. That's the power consumption of the inverter, I think. So if you don't need it, turn it off. It's consuming. DC is also, I mean the USB, that is not consuming, or not that much. It shows 0 watts. So one is not cancelling the other, you can leave those connected also. DC, that's that. And AC is here. So DC, USB and AC. Turn off, and turn off, and turn off. Okay, it has a lamp. No, short press is not okay. You have to long press it. It's pretty powerful. Pure sine wave, it says on this side. Nothing else here. And nothing here, maybe a fan. Now let's plug it in for the first time. 220 volts AC. We have a green LED there, and that one should go here to the input. A green LED turns on there also. The fan also turns on slightly, and it's charging. If I unplug this one, everything turns off. LED is still on, it's off. So it looks like this when charging. Fan slightly turns on. Output watt nothing, input watt 53, 67, 80 watts, 90 watts. It's almost consuming 100 watts. Just like my electric scooter when it's charged. So this will heat up a little bit, I think. Don't keep it on a soft and warm surface. You cannot power it on while it's charging? I guess not. I mean, it is on. That means that you cannot turn it off while it's charging. No. AC, USB and DC. So whenever it's plugged in, it turns on. It's powering itself on and you can use it. And will the power button turn them off? Like so, no. And like so, yes. If I power it back on, it's not turning them automatically on. They remain off. If I plug it in, nothing is changing, but it's charging. I'm charging it from 220 volts. And meanwhile, let's see if I can charge my phone. It says 20 minutes until full. Let's disconnect all those. Output 9 watts, it was 22. 19 minutes until full. Okay, and let's try the quick charge. It says 20 minutes until full. The phone itself is at 90%. Quick charge starts charging slower. It's analyzing things. Whatever, but it's working. Here's a heat gun. It's blowing hot air and it's consuming 300 watts. The output, I think it's 500 watts. Nothing. it's not working because this one, the USB is enabled and AC only now is enabled. So AC is enabled, 98 watts are inserted into the battery and 30 are already used by, I guess, the inverter. Yes, output 0 and 40 watts, 11 watts just by powering the inverter and doing nothing. Now let's power on this 300 watt hot air gun. It's working. 175 watts, 269. No problems. Once again, it's going down to 14. Input is constant 98. Output is almost 300 watts. That's a good tool. By the way, power it on from here, power it off from there. It stopped. Now here's a drill and here's the battery. Let's power it on. Let's see, will it charge? Now it's charging. 20 watts, 40 watts. So this charger of this drill is consuming 41 watts from the AC side. If I remove it, 41 goes down to theoretically 11, 14. Yes, probably this is also consuming a little bit. 13 goes up to 40. Yes, 40. So it can charge your batteries from your drills. And here's the manual. Now it's not flashing and it's still 100%, but it's still getting 42 watts. So now it's also 100, but the input is 0 and 100%, so it's fully charged. Unplug and turns off. Green LED later. Yes. Now I'm inside the car and let's try to charge the battery for the first time using this plug. No LED. Okay, no LED. Now this end, which looks like a laptop connector, should go there. Green LED turns on and we should have some input. Of course it's almost fully charged. Maybe that's why it's not showing any input, but at least it's working. From the car's 12 volt plug into this one, in around 1 week it discharged 3% from 100 to 97 by itself. I made another wire. This one has an XT90 male connector at this end and a female 12 volt connector. It's also heat shrinked because these connectors are pretty fragile. And the solar panel also has an XT90 connector like this one, but a female, because the female is protected. On the male you can make a short circuit like this by inserting a metal object between the plus and the minus. You can make a short circuit. You cannot make a short circuit on the female one because that is filled here in the center. Okay, so this should come here like so, the yellow one to the solar panel and this one into the battery pack. And the 12 volt 100 watt solar panel can charge the battery pack using this cable. And here's a 12 volt fridge. Cart is packed with other stuff. Off, center is off. Okay, and let's see what will happen. Power it on. Start the DC for this one. And it's working. It's blowing warm air out here and it's blowing cold air inside here. 12 volt fridge running from this battery pack. And it's consuming around 51 watts of power. If I press this, it turns off. So it's working. Here's the fridge and the battery pack. Now let's see how long can this battery pack power this fridge. Okay, and long press this one, 99%. This also made a click sound. By the way, it's 2 hours and 37 minutes. And DC is not yet on. This turned on. So it started at 2 hours and 37 minutes. And the battery was at 99%. Let's see how long can it run. The fridge on that battery pack. Output wattage is 43, so the fridge theoretically consumes 43 watts of power when using this one. When it's using the 220 volts connector, which is inside here somewhere, that one probably through that is consuming a little bit more. 40 watts being consumed. After just a few minutes, here the metal, the shiny metal, is pretty hot. Maybe it's not making contact. It even stopped. Bad connection. It's not making connection. This tip is very hot. Ouch. It's very hot. Now it has a higher RPM. Now it says it's consuming 43 watts, 42. And if I move it to the left, it has a higher RPM, 46 watts, 7. 44 watts to the right, 46 to the left. At 4 o'clock and 47 seconds, it's at 80%, and this is slightly warm. Now here's the 100 watt solar panel, and for the first time I'm going to try to connect it to the battery pack. So I have an XT90, those are just blue heat sinks on it. XT90 connector goes to the 12 volt car plug, and the other end is this input, which is for this one. So currently it says 0 watts input, 44 output, and it's at 79%. So I'm plugging it in. 17 input, 14 input, 54, 65, 70. It's gradually increasing. So that's a 100 watt solar panel. Of course the sun is down a little bit, but there are barely any clouds. And we are getting 76 input and 43 output. So theoretically it should charge, because what enters is larger than what exits. If I remove this one, 75 is not modifying, so we are not getting 100 watts from the 100 watt solar panel. I have to move it to the left because the connection is better there. So we are charging and we are discharging this battery pack from the solar panel. When the battery pack is discharging through this one, for example, then the blue line is not flashing. And when I plug in the input from the solar panel, this is charging, then the blue line is flashing. So when it's flashing, it's charging. When it's not flashing, it's discharging. So I'm going to drive 34 kilometers and I'm going to charge it. And let's see how much can I charge it in 34 kilometers. Currently it's at 63%. Through this plug. So the battery pack is being charged with 79 watts from inside the car through the 12 volt connector. And if I stop the engine, then it stops. And after 43 kilometers we have 77%. So here's this solar panel. Those are my legs for size comparison, and I connected it to this battery and it was not doing anything. Let's see if I disconnect it. Yes, it turns off. Connected back, the LED should be green. Yes, it's green. There's nothing. Now it turns on. Before it did not turn on. So just by inserting the power wire, the display should turn on by itself. And you should see some input wattage there. So once again, unplug the cable. There's nothing on the display. It's dark. So you don't have to power it on from that button. Insert the power, and now it should automatically turn on by itself. 97% charged, and theoretically through the output of the battery bank I should be able to draw 500 watts, and I connected a vacuum cleaner which is I think more than 500, 1000 maybe, and let's try to power it on. Let's see what happens. It usually turns off, so currently it uses 10 watts, that's the inverter's usage, so I'm powering it on. It starts up slowly and it turns it off. So let's power it on again. 100 watts, 700 watts, so it's already more. And 744 and turns off. Let's try it once again. So it's asking more from it. 92, 600, 700. So at around 700, let's say 50, it turns off. Okay, so you cannot run a vacuum cleaner off of this portable battery. Desktop computer and monitor are connected to this battery thing, and it's consuming 32 watts of power. If I unplug this, this is powering both the monitor and the PC. Then from 32 it should go down to 11, 26, 10. So this is unplugged. So the computer, although it's turned off, it's consuming around 20 something watts. So from 10, now it's plugged in, this one, it goes up to 28 watts. Power on the PC. This fan should be silent in a few moments. 150 watts are consumed from this device. The output is rated to 500 watts. Now it's consuming 260, 183 watts. The monitor starts. Windows is loading. 200 watts are being consumed from this battery. Loskii LK-PS10. And voila! DaVinci Resolve desktop computer running from this. If I would press that button, everything would stop. Let's try it. So I'm pressing this button and everything should turn off there. 3, 2, 1. Yep. No more power consumption. Output went down to 0. The inverter is off. That's why it's 0. When the inverter is on, 220 volts are being output there. That goes up to theoretically 10, but since this is plugged in, it's not just 10. 10 watts is the consumption of the inverter itself, which is built into this one, but with the PC also connected, 46 watts, 55 watts, although that the PC is off. Power it back on. Let's see how long can I use this device to power my computer. Now it's pretty charged up, it's at 96%. Current time is 21 and 41 minutes. 96%. Playback of video in DaVinci Resolve consumes 264 watts. DaVinci Resolve is rendering a video and the GPU is around 60% utilized. It's a GTX 1070. 260-70 watts of power are being consumed by that monitor, by that desktop PC, from that battery pack. And the fan just turned on. Battery is at 44%. 250 something watts are being consumed by the PC. It's just a little bit warm. The box itself is not warm, the top is warm. Now the time is 22:49. 44%. And a few seconds later, the fan turned off. Now it's silent again. Here on the top is warm. Not burning, just warm. Nothing here, no heat. Now it's consuming 183 watts. If I power on my monitor, it's consuming 190 watts. 99. Of course, when this battery discharges, the computer has no clue about the voltage level of those batteries, so Windows will not turn off or not enter into hibernate mode or sleep mode. The power will be simply cut off because the inverter of this battery pack will turn off. Currently it's at 26%. Let's see what will happen when it reaches around 0%. Battery is at 12%, just one line. PC is consuming almost 200 watts. I'm uploading a video to YouTube. Hope it will finalize before the battery is discharged. So this is powered by the battery. Keyboard is also powered by the battery, and the display currently is not powered, is off. It's at 7%, but it refuses to go down. It's on 7% for a long time. 23:54, and it's still working. Lights are rendering and the monitor is on, and it's at 3%. Let's see what will happen. 2%. Ouch. 0%. And it stopped. PC is off. So it says that the battery is at 0%, but the LCD is on. It didn't turn off. The inverter theoretically is on. Yes, it gave power to the monitor. Can I power on the machine? Yep. 0%. PC turned on. 180 watts are being consumed, and 0% is the battery of this Loskii. PC turned off. Time to recharge it. Time is 0 hours and 20 minutes. Press and hold that button. Light turns on. Battery is at 0%. Light is on. So when the battery theoretically is dead, you can still do some minor things. Can't turn off from here, but from there.